Today, we talk about chapter 4.2, limits and infinity. Okay, there are two parts in this session. Okay, first is about the concept of infinity. So, let's start. Okay, concept of infinity. Well, the concept of infinity actually is not difficult. Okay, remember in S1, you learn something like number line. Okay, then, suppose the middle is 0, then here it may be 1, 2, and the negative sign will be at the left hand side of 0. So you get this 2. Okay, and then so far so on, you will get 3, 4, and then negative 3, negative 4 here. So actually this line can be extended on both sides, so we have an arrow. So for the left hand side, actually you can imagine it will tend to negative infinity, means a very small number, and then for the right hand side it will tend to positive infinity. Okay, we use this notation to represent the infinity. So here just simply give you a remark. Okay, so although we will use positive infinity and negative infinity to represent some concept, but these two bear in mind, they are not real numbers. Actually, they are not numbers. Okay, so this is like the concept of infinity. Okay, then now let's go to part B. Part B is about the limits of infinity. Actually, this is the focus of this session. I will use two examples to show you about this. So example 1, let's consider a function f(x) equals to 1 over x. Now what is the value of f(x)? The question is when x approach let's say positive infinity. So here you can imagine x, when it is a very big number, just imagine it is like this number. Then what is the value of f(x)? I think you should be able to imagine it should be 0, right? Then we can write in this way: when x tends to positive infinity, what's the value of f(x)? Is equals to this. So when x is a very big number, this will become 0. Okay, then how about negative infinity? Okay, it's simply like you put a negative sign here, right? Then 1 over this one, you still get 0, right? So in fact in this case, we also have x tends to negative infinity. Is equal to the same. 1 over x is 0. So these two limits are all both equal to 0, but just another remark for you. This is quite important concept. Actually, f(x) it will not equal to 0 for all values of x. That means if x is a number, then you put it into the function, it will never equal to 0. So example 2. We consider another function. Which is let's say 3 to the power x. Then what is the limit of this function when x tends to positive infinity? we can try to figure out. So imagine when x is a very big number, then this value will become a very big number. Actually, it will becomes bigger and bigger. So in this case, we can write this is actually equal to positive infinity. So this means, although it is equal to positive infinity, but as I said, positive infinity is not a number, so this means the limit of v to the power x when x tends to positive infinity does not exist. Then how about the case when x tends to negative infinity? Is it the same? So we can look at it. Imagine if x is very small this time, then what's the value of v to the power x? You can imagine by, let's say, what we put x, negative 100. So what's the value of this? Then it will become 3 over 100. 1 over 3 over 100, 3 to the power 100. And then it actually is very close to 0. So this situation is different from example 1, when x tends to negative infinity, v to the power x is equal to 0 this time. So actually we can find in general, limit x tends to positive infinity, a to the power x is equal to positive infinity if a larger than 1. But when x tends to negative infinity, it will become this. Sorry, not negative infinity, sorry. It is 0. If a greater than 1. Then you may ask, how about if a is not greater than 1, but between this one? I can just use one case to illustrate what to do. If you get this time a, for example, is 1 over 2, then what should we do? We can make use of this. 1 to the power x is still 1, right? So we can get 1 over 2 to the power x. Then what is the value of this when x tends to infinity? This will also tends to positive infinity, right? Because now if we only look at the denominator, it is 2 but not 1 over 2. So we can make use of this case, right, for the denominator only. So 1 over positive infinity means you will get 0, right? So that is the case. So you can simply write limit x tends to positive infinity becomes 0. Then similarly, if you get negative infinity, you should be able to work out this is positive infinity this time. So now we just simply go to the textbook, some theory. Theory 4.4. Let me explain a little bit this free theory. Okay, if x tends to positive infinity, fx is okay like a very very big number or a very very small number. Then if 1 over fx, okay, like if this is positive infinity or negative infinity, then 1 over 8 it will become 0. So this is theorem 4.4. Okay, for theorem 4.5, actually it simply like those you have learned before. So and also theorem 4.6. So I think we better go into practice, okay, instead of look into the details of this. So now I need you to do quick practice 4.6 to 4.7. Okay, I will show you the answers in another video.